Hi dear students, welcome to Bosco Campus Vision. This is Seema Dudley. Welcome to my another video on the topic Internet of Things. In the last videos, we were discussing about a simplified IoT architecture, and we have seen that this architecture, IoT architecture, can be divided into two different portions, that is the core IoT functional stack and IoT data management and compute stack. And this core IoT functional stack can be layered as the first layer as the things, second layer as the communication network layer, and we were discussing about the different sub layers in the communication network layer. We have already discussed the access network sub layer, and in this video we will be discussing the other sub layers, that is the gateways and backhaul sub layers, network transport sublayer, and IoT network management sublayer. So the second sublayer of the layer communication network layer is a gateway and backhaul sublayer. We know that data will be collected by the smart objects, and the data collected from a smart object may need to be forwarded to a central station where the data is being processed. As this station is often in a different location from the smart object, data directly received from the sensors through an access technology needs to be forwarded to another medium, that is the backhaul, and then it should be transferred to the central station. And the gateway will be acting as a medium for communication, that is in between. ഇതിന്റെ രണ്ടിന്റെയും ഇടയ്ക്ക് ഒരു communication medium ആയിട്ടായിരിക്കും this gateway act ചെയ്യുന്നത്. So for communication, in most cases the smart objects are static or mobile within a limited area. So the gateway is often static. However, some of these IoT technologies do not apply this model. For example, dedicated short-range communication, that is DSRC, dedicated short-range communication, allows vehicle-to-vehicle and vehicle-to-infrastructure communication. And in this model, the smart object's position relatively to the gateway is static. And the car includes sensor and one gateway. Communication between the sensors and the gateway may include wired or wireless technologies. Sensors may also be integrated into the road infrastructure and connect over a wire or wireless technology. And the wireless technology DSRC operates in the upper 5 gigahertz range, and it is used for backhaul communication. And in unstable or changing environments, commonly used technology is the wireless technology for connections, and Wi-Fi is a common in case of unstable and changing environments. And mesh is a common topology to allow communication flexibility in the unstable type of environment. Now we can check the architectural considerations for WiMAX and cellular. And here we have a table indicating the technology, type and range, and architectural characteristics. So we can check the technologies one by one. First technology is Ethernet, and it is a wired type technology, and the range is maximum of 100 meters. And some of the characteristics of this architecture is it requires a cable per sensor or a cable per sensor group, and it is adapted to static sensor position in a stable environment. And the next technology is Wi-Fi technology, and it is a wireless type, and its range is up to 100 meters, and It can connect multiple clients and its range is limited. It is adapted to cases where client power is not an issue. The next technology is the 802.11h, and it is also known as Hello, and it is a wireless type, and its range is up to 1.5 kilometers. The architectural characteristics of this technology is it can connect a large number of clients, and it has longer range than the traditional Wi-Fi. Some of the characteristics or the features are it is power efficient, it has a limited bandwidth and low adoption, and its disadvantages we can say as its cost is very high. And the next technology is a WiMAX technology. It is also known as 802.16. It is also a wireless type, and its range is several kilometers. And its characteristics are it can connect a large number of clients. Also, large bandwidth is available in licensed spectrum. And another technology is that cellular technology, and it is also a wireless type, and its range is also several kilometers like WiMAX. And its characteristics are it can connect a large number of clients, and also large bandwidth is available. The next sublayer is a network transport sublayer. For communication to be successful, network and transport layer protocols such as IP and UDP must be implemented to support the variety of devices to connect and media to use. This in the previous layers, that is, in the previous layers, we were discussing about the hierarchical communication of architecture. That is, the sensors will be creating the data, and that data will be transferred to a central station through a gateway. Okay, അപ്പോൾ നെക്സ്റ്റ് സെഷൻ എന്ന് പറയുന്നത് the network transport sublayer, and communication successful ആകണം എന്നുണ്ടെങ്കിൽ it should have a um, this protocol should have a specific characteristics. Okay, and the protocol needs to be open and standard based to accommodate multiple industries and multiple media. And scalability and security is also a requirement for this uh, protocol. And IP is a protocol that matches all these requirements. And the next layer is a IoT Network Management sublayer. The additional protocols must be implemented in place to allow the head-end applications to exchange data with the sensors. This IoT network management sublayer, IP, TCP, and UDP bring connectivity to the IoT networks. The upper layer protocols need to take care of data transmission between the smart objects and the other systems. These multiple protocols have been leveraged or created to solve the data communication problems in IoT. And the networks rely on different models like push model, pull model, or the hybrid models. Push model means that is a sensor reports at a regular interval or based on a local trigger. And this pull model means an application queries the sensor over the network, or this networks can use the hybrid approaches, that is the combination of push model and pull model. And some of the IoT implements, they will be using the HTTP protocols. And after all, this HTTP has a client and server component, and the sensor could use the client part to establish a connection to the IoT central application, and then data can be exchanged successfully. Even though some of the IoT applications uses the HTTP protocol, this HTTP is something of a fat protocol. That is, it has some disadvantages, or we can say limitations, like low memory, low power, low bandwidth, and has a high rate of packet failure. So, new technologies have been developed, and one example is WebSocket. WebSocket is part of HTML5 specification and provides a simple bidirectional connection over a single connection. Some IoT solutions use WebSocket to manage the connection between the smart object and an external application. The WebSocket is often combined with other protocols such as MQTT to handle the IoT specific part of communication. Some of the additional protocols created are extensible messaging and presence protocol, that is XMPP. XMPP is based on instant messaging and presence. It allows the exchange of data between two or more systems and support presence and contact list maintenance. And the limitation of XMPP is its reliance on TCP, which may force subscribers to maintain open sessions to other systems and may be a limitation for memory constrained objects. And to overcome these limitations, and the protocol was created by IETF constrained RESTful environments, that is core working group, that is the CoAP, constrained application protocol. And this CoAP uses some methods similar to those of HTTP but implements a shorter list, thus limiting the size of header. And this CoAP also runs on UDP. CoAP also adds a feature that is lacking in HTTP and very useful for IoT. Another additional protocol is this MQTT. MQTT means Message Queue Telemetry Transport. Message Queue Telemetry Transport uses the broker-based architecture, and this sensor can be set to be as an MQTT publisher, that is publishes a piece of information, and the application that needs to receive the information can be set as the MQTT subscriber, and any intermediary system can be set as a broker to relay the information between the publisher and the subscriber or the subscribers. So the MQTT runs over TCP. Finally, whenever we are building an IoT system, we have to give importance to security. An assignment question connected with this topic is: explain the different sublayers of communication network layer. Complete the assignment and forward it to the email ID provided to you. Thank you.